Welcome everyone to Knox Game Design for March 2025. My name is Levi Smith. So this month I'm going to be talking about simulation games. So what is a simulation? Well, the dictionary definition of a simulation is the imitative representation of the functioning of one system process by means of the functioning of another. So basically, first, it's got to be imitative of a real world process, something that currently exists. And it also mentions the one system, the system being a collection of components or an object by the functioning of another system, interactivity between those two systems. Second definition is examination of a problem often not subject to direct experimentation by means of a simulating device. So basically, you're taking a real world process, simulating it through a computer. So that makes me ask. I mean, this is something that I've always wondered: is like, what exactly is a simulation? So you have like a racing game that could be a simulation, or a flight simulator, or even a sports game, a football game, or baseball game. You consider that to be a simulation because it's a real world process. But typically, those aren't called simulation games. So maybe a simulation is defined by what isn't a simulation. So if it's already a sports game, or it's already a racing game, or it's already a flying game, then it isn't a simulation. So maybe everything that does do the representation of real world processes that isn't already considered, that doesn't fit into any of those other genres. Maybe that's what a simulation. That's what a simulation meant to me when I was a kid, like back in the '90s, and they had simulation games on the NES and Super Nintendo. The other thing is like, well, again, I mentioned, yeah, it's the many objects functioning together. So a racing game, you have a car in the road, but you don't have the interactivity between a system of objects. And with a sports game, you have the players, but you really don't have many numbers of things interacting with each other. And the other thing that I consider a simulation back when I was a kid to be considered a simulation game is usually open ended. There was no end state. You just kind of ran it and see what that you could get. There were objectives. And I want to talk about some of the games that I played when I was a kid, but no finite end state. You don't defeat the final boss. So here's some of the things I was thinking about. Like I mentioned earlier, a real world process. Another thing is customizable inputs. To be a simulation, I think you got to be able to have inputs into the system. Um, it's open ended, as I already mentioned. Many variables working together. You can pull in physics, things like that. Multiple outcomes, no finite outcome to a simulation, and the interactivity between objects. So I guess that leads to another question: is, are simulations games? If that's a simulation, then what is a game? Does a game have to have a win state? That's the distinction between a simulation and a game. Typically, we call things. These are some of the ones that I played when I was a kid. SimCity. It's got sim in the name, and all the derivations of the sim games, such as Sim Earth and Sim Ant. All of those are what I consider to be simulation back in the day. And also, I had Wall Street Kid. I didn't play that until recently. Always considered that to be a simulation game, but I didn't know much about it. Basically, stocks, you buy and sell stocks. But is Wall Street Kid really a simulation? You got the stocks, but the stocks really don't interact with each other. I mean, they're kind of random. I guess a stock market game could be a simulation if you do add the variables or interactivity between the objects. Definitely, it's open ended, no win state. I mean, you can make goals to get so much money. I know there is goals throughout the game to reach, but it doesn't have that finite end state. So one thing I want to mention, one thing I was looking into is going back and looking at SimCity. There is a free and open version of SimCity out there. It's called Micropolis, and this has been out for years, I know, but it's an open source release of SimCity. I don't know how difficult it is to compile it, but you can go out and it's actually on GitHub, Micropolis, and you get the code here. And there's many different versions. People made like Java ports, JavaScript ports, and here's one right here called Micropolis JS. It's a neat game, a neat implementation to look at, where you can just play SimCity basically online. It doesn't have all the frills and everything of the Super Nintendo version, but it is pretty cool to go back and look at. So one thing I wanted to do was to actually go back, and because I never really understood exactly how these residential and commercial areas grow. Um, so, by the way, anybody that's not familiar with the original SimCity, basically you have three zones: residential, where people live; commercial, where people buy and shop; and then industrial, where people go to work. And then you can build roads between these to connect them together. I don't know why my commercial areas are not growing here. Kind of strange. But you also have to connect all these up with power lines to a power plant. You have two different types of power plant: the coal, and the nuclear. You can also have things like police departments. So you, in this Knox game design is downtown, you do have other factors such as crime especially in the industrial areas. You can make a fire department, and you can see the residential zones, commercial zones, and industrial zones are all related together. If you don't have the correct balance, and that's what the graph is in this lower left-hand corner is over here. So it kind of guides you to build the correct proportion of these zones together. So definitely a simulation game. Some people call this a building or construction simulation. I guess that distinguishes it from all the other types of simulators out there. But yeah, definitely a game. I mostly played SimCity on Super Nintendo when I was a kid. Never really played the computer version, but definitely something to check out. As I mentioned here on the slide about the RCI, they call it RCI, residential, commercial, and industrial zone. So it's definitely a simulation. You have those three zones interacting together. I mentioned electricity. One other factor is pollution. In industrial zones, you have a lot of pollution. Reduce that with parks. So there's this balancing of things you can add to reduce the factors such as pollution areas. And then you have transportation. If people can't drive to or ride a train to their job, then they can't work. So the one thing I really wanted to do is go look at the code. I'll admit I didn't do it, but I wasn't able to compile the SimCity code. I really didn't even try, or Micropolis code. But one thing I really wanted to look at is to see what the actual formulas were for how fast those zones grow and what are the limits. That's something for another time. So another simulation, one of the ones I found out about a long time ago, is Conway's Game of Life. So it's a simple simulation. You have a grid of cells, and start out with a set number of cells alive that are either on or off, true or false. We're going to call it alive and dead. So each cell has kind of like the Mega Man select screen. You have 8 cells around it, the center cell. So you have different generations. So for each generation, cell will die if it has less than 2 neighbors alive. They say it dies of loneliness. A cell with 3 neighbors will live. A cell with more than 3 neighbors dies from overcrowding. And then a dead cell that has exactly 3 live neighbors will become alive. So it's pretty neat. Nice programming problem to implement for beginning. Um, so simulation is determined by initial configuration. So you determine what cells are alive at the beginning, then you tell it to go, then you have no other control of it after that. As I mentioned, good programming project if you're just starting out. The question is it a game? I don't think so. It's a simulation, but not really a game. You don't really play it. I guess you set the initial state, but I guess you could gamify it. That's what I have on the last point here. You could actually make it a game. I mean, I think it's really neat. Could be the really neat basis of a game where you give cells different properties. Yeah. So that was one of my first uh, programs, graphical programs that I implemented in Allegro back in 2001. I think I was like right in the middle of my undergrad degree at Georgia Tech, science. But we really didn't do a lot of game programming or graphical programming, so I wanted to do. So I kind of did this as an outside project right here. And I thought this had been lost in the ether or to the ether. So I was going through some old files on a disk. It's like, there's the code. I found it. And so luckily I was able to actually recompile this using the old DJGPP compiler. So I did a talk on Allegro probably a couple of years ago for Knox Game Design. The video's out there if anybody's interested in doing stuff in Allegro. So yeah, look at the December 2020 Knox Game Design presentation. So the one thing that still threw me for a loop. So you got to run this through DOSBox because it's like Allegro 4 or 2 or something like that. One thing you got to watch out for. I had to go back to the old. So here's DJGPP. It's still after all these years. DJGPP is still out there. Delory.com. This has been up for like at least since 2001, which I think is pretty cool. So when I was trying to get this to run through DOSBox, you'll also need a copy of DOSBox, which is free. One thing you want to make sure is to click check Allegro down here. You want to use the Allegro from the DJGPP site. So this is the zip picker. Then you just say, what files do I need? You download all these files here, and then you put them all in the same directory, and it magically works. Now, if you download DJGPP for DOSBox and you go out and get the latest Allegro, it's not going to work. Latest Allegro libraries. If you go out and get the Allegro 422, that's what it is, it's still probably not going to work without a lot of work, a lot of effort. But if you download them all from here, then I had success with that. So here it is. I don't know if I want to look at the code. It's probably ugly, but here it is running in DOSBox. Yeah, so here it is. Not the prettiest code out in the world. Probably one of my first C programs outside of actual assignments for class. Don't know how hard that is to read. Make it bigger. But yeah, I mean, it's all right. It does the job. Got a lot of different options in here. Where it's checking the neighbors, rules for the cells. I'm gonna go through. There's the delay for generation, cell number, setting up Allegro. So yeah, none of this works in Allegro 5, by the way. So yeah, that's all good. Just showing that's the source code. I did put in a make.bat. That's all there is to it. GCC, Conway.c. Output Conway, library Allegro. So DJGPP does see. Sorry, ran that. Do Conway. So it gives you some options. I just do auto detect. Resolution, I'm going to do 320 by 200 just because it's going to scale it up. If you do 800 by 600, then it's going to be really small. It's not going to scale it up. So let's do 320 by 200. Then we'll just do 32-bit color. And there it is right there. And what's nice, I can press R and it will generate a new set of input. So it's pretty interesting. You can see some of these kind of just like loop. Some never change at all. And then some expand. You get some really nice geometric patterns here. You can actually slow this down with D. You can really see like each, what they call generation, each loop. You can also change the colors by pressing C. So if you red, get it in red. Speed it up really, really fast. If you make it too fast, it just kind of looks like ooze going all over the place. So I was so happy to find this. I thought this was lost for. It's kind of interesting. Like some of these patterns, they start out mirrored, symmetrical. Then, in one of these little guys that aren't moving, they kind of bump into it. Then mess it up. There's a blue. Blue's probably kind of hard to see. There's green right there. So yeah, one of my first graphical programs way back in the day. So you can't pick the initial state. It generates, I don't know, a few different random positions. Could be updated. There's a magenta right there. So yeah, I don't know if you'd consider this a game or not. Oh, here's one. It just has one that's spinning. So I went out and just curious. I never really. I think I might have heard like we might have talked about it once or twice back in Knox game design back in the day. There might have been some talk about Conway's Game of Life. Last slide. But never really heard much discussion about Conway's Game of Life. So I went out to see if anybody's talking about it. And there's a whole wiki. It's called conwaylife.com for everything you want to know about Conway's Game of Life. All these different articles. So what I didn't know is there's actually names for all these different patterns in Conway's Game of Life. So they got one called Methuselah. I know Methuselah was like the oldest guy in the Bible, or he lived the longest. Genesis in the Bible. So they got these called Methuselah, and I believe that's because they just live forever. They don't ever go away. They don't ever change. Yeah, it takes a large. Okay, so it takes a large number of generations for it to stabilize. So it may change, but after a number of generations and a number of leaps, and they stabilize into one pattern. So these are the Methuselahs right here. So somebody's done research on all this to figure out all the Methuselah. They got one called the gun. It's a stationary pattern that emits spaceships or rakes forever. So it kind of like shoots things out. So I thought that was pretty cool. They call those guns, and then they got like like who discovered each of these in the year of discovery. So here's one 2025 figure. So people are still like discovering different patterns in Conway. They got one back in 1970. I did not know there was still a Conway's Game of Life community out there. That's pretty wild. So then they have oscillator, a pattern that is a predecessor of itself. So I guess it kind of goes back and forth. Ping pongs. Not as many. There's some 2002. A lot of discoveries of these out there. I did not know there was an active community of people discovering different patterns. Well, it kind of looks kind of like the same people. Same group of people. They're still at it, finding all these. There's a still life. So I think these just never change, have the same condition. They never die and then come alive. Have constellation. Constellation is a still life that is composed of two or more interacting objects. It's two or more, but they never do change. I think I saw some of those in simulation. Here's some examples of constellations and count this quasi still lives. It's like, yeah, there's still an active Conway. And here's a spaceship, also referred to as a glider, or less commonly as a fish, commonly shortened to ship. A finite pattern that returns to its initial state after a number of generations, but in a different location. So it kind of just like moves along to a new location. An almost night ship. This is crazy. I love it. I love it. that people are still like doing stuff with Conway's Game Alive in 2025. I don't know. Maybe I'll do some stuff. Maybe get back into the Conway's Game Alive. I don't think I'm going to be out here like discovering these or anything. I don't see. There's a copperhead spaceship right there. But I think this could be used as the basis of a game. So I was kind of just even like thinking for that RPG that I was developing, using kind of like some of these patterns for enemies or characters, things like that. I think that would be make a game out of it. I'd have to think a little bit more. So anyway, that's it for simulations. Not a very long talk, but something I don't think Knox Game Design has ever talked about before. That is worth mentioning. One announcement: got Knox Game Jam coming up. We're gonna have a kickoff next Friday, April 4th. That is next Friday, right? Friday of next week. So basically what we've always done in the past, 48 hours. We're going to do a kickoff at 7 p.m. meeting at Panera Bread on North Peters Road. Just for kickoff, for ideas, brainstorming. I was wanting to do like a way people could submit themes through the Discord channel and have a bot come up and pick up the themes. Then randomly pick one, but I just don't have the time and energy to do much anymore. That's just an idea. Maybe next time. Goal is to make a game in 48 hours. Use any game engine or library. Some suggestions: Unity, Godot, Unreal, Game Maker, Monogame, Allegro. And your game is your prize. No voting or anything. Just make a game. People in Knoxville, even if you're not in Knoxville, participate. If you go to knoxgamedesign.org, the first post right now, got the information there. We are using itch.io for the jam. It makes posting jams easy. So you just click there, itch.io/jam/knox-game, knox-jam-25. Going in here, submit your games here. So additional information on our Discord channel. So that's gonna wrap it up for Knox Game Design 2025. Appreciate everybody out there listening and watching.